have studied about communication networks, I have explained about the content addressable memory cell design using transistors. This is the similar concept. In the cell design, we have always NMOS, and we also have the PMOS. NMOS don't have a bubble here, but PMOS will have a bubble. So we know this is a gate and drain and source, the same gate and drain and source. This is NMOS, PMOS. So if we connect them together, then that is called CMOS, right? So usually this PMOS will be in the top. So let's just say like this. So here you are applying the VDD, and here you have the NMOS, and this is grounded, and you can just connect these two gates together and apply the input. So you are applying the common input to both gates. For example, if you apply 0, then what will happen? 0 will always turn on PMOS transistor. And you know the backside, the backend device physics, because you know, whenever we have PMOS, then what is the majority carriers? That is the holes, that is the plus. And whenever you have this NMOS, you have the majority carriers as the electrons. Okay, this is a device physics. We don't need to go into that. So this is the holes, it's the majority carrier. So according to this, so whenever you apply 0 to this both input, this PMOS will turn on. So this VDD will travel through this this source to drain, and then it will reach this part. And here the VDD cannot travel further down because this is open. This is short circuited because of the gate. Here it's open circuited, so we can get the output as the equal to VDD. If you apply the VDD as a plus 5 volt, in digital world, we do not call this a high voltage or low voltage. We call this a logic 1 or high. Then we will get 1 at the output. So it's just inverting. Whatever you apply here, it's just inverting at the output. That is the purpose of CMOS. And similarly, if you apply 1, then what will happen here? 1 cannot turn on. So this PMOS will be off. So it means this is an open circuit, but this 1 will turn on this NMOS. Then there will be a conduction between this source and drain. Then this ground will be pulled up towards up, and you will, ground means what? That is the low voltage, right? That is a 0 in digital world. So this 0 will come here, and then we will get it here. So just try to remember this concept, because this push-pull and open drain is everything is depending upon this CMOS operation. All the microcontrollers and microprocessors are implemented by using CMOS transistors. That is why we call the fundamental design unit of any microprocessor and microcontroller design is CMOS transistors. You know, in transistors, we have so many different types. We have BJT, bipolar junction transistor, and we have FET, field effect transistor, and we have IGBT, and we have SCR. There are so many different types of transistors, but of course we have the diode, but this MOS is one of the very influenced one in the digital world, metal oxide semiconductor based transistors. So this is what the MOS, and the MOS has two types, PMOS, NMOS and PMOS. Where is PMOS? This is PMOS and this is NMOS. And when you combine this PMOS and NMOS, you get CMOS. So all these microprocessors and microcontrollers are implemented by using these CMOS transistors. Inside one microcontroller, there are millions of CMOS transistors available. So we compact the size. So simply we call this as a VLSI, very large scale integration. So before we had a LSI, large scale integration, and then we improved to this VLSI. Of course, we also have another one called ULSI, that is ultra large scale integration. So integration means what? We are integrate so many things into one small pack. So we are integrating so many transistors, this CMOS transistor inside. Each CMOS transistor consists of two transistors, that is the NMOS and PMOS. So that is why it has a millions of, even if we can say in some processors, billions of transistors are available within a single chip. And each transistor, any transistor you can take, and the transistor can work as an amplifier or switch, right? So this is the general purpose of any transistor, amplifier or switch. I think these things you have studied in your electronics course. So amplifier or switch. But in the digital world, we are not using transistor as an amplifier. We are using transistor as a switch. It means whenever you apply the gate voltage, you are controlling. So if there is a gate voltage, then only there will be a conduction between the source and drain terminals. Otherwise, there will be no conduction. So this is how we are taking the logic 1 at the output or logic 0 at the output, and we can perform by using this logic. We can perform so many operations by using this logic. The whole digital world is depending upon these CMOS transistors, and we are using this logic in whatever, in your mobile phone, in your laptop, or any kind of digital signal processor is based on this logic. This is the very, very fundamental logic. Of course, you can build, when it's not a matter you have 100 transistors or 1 million transistors. That's not a matter. All the transistors are using the same logic. Of course, we have the rail, so high voltage rail, and then the low voltage rail, ground rail, and then we have so many transistors are connected in with a common high voltage and common ground. Then it will work accordingly, according to the logic you are implementing. That is why we have this field called VLSI. So you can design the microprocessor or microcontroller using this VLSI technology. So we simply call this a very large scale integration uh, technology. You can use some kind of programming languages to write any function. So yeah, anyway, I think we don't need to go inside, but as a digital electronic students, you must know what is this VLSI. This is one of the very important part. You have to know that because the entire digital world is depending upon this VLSI systems. So all the ICs, that is why we call this as an IC, integrated circuit. So we can design any integrated circuit. For example, I want to design one microprocessor, especially in the microprocessor, one module, let us take, that is a ALU. I want to design this ALU. What ALU has? ALU has adder, subtractor, multiplier, comparator, everything is inside this ALU. So I can write a program to write the function of this adder. For example, I can write the adder like for, yeah, what is the adder? Just like a sum is equal to a plus b. If you have two input, you are getting output as the sum of these two variables. So this is a variable. This is not a fixed value. So you can use any value and you will get the addition of this here as the result, right? So I can just add, I can write the program like for this one. So of course, I have to declare the variables, and then I can write the statement, and then I will end this one. This same like the C language programming. And then you have to do the synthesis. Of course, you have to do the simulation and check. You can apply the clock signals and everything is synchronized, and then you can check the output, and then you can use the synthesis. After the simulation, you have to go through another processes. Synthesis means this program, there are so many tools for this synthesis. For example, you can use the Synapsys. This is a company, it's a very big and famous company for digital design. You can use this Synapsys company, they have a technology libraries. So maybe let us say like they use now 45 nanometer technology. So you can synthesize this circuit by using the technology library provided by some companies and their tool. And this one will take logic gates. You have studied about AND gate, OR gate, NOR gate. and or not. So many gates you have studied about NOR, NAND, XOR, XNAND, XNOR. So there are so many gates, right? So the technology library is really based on these gates. These gates are implemented by using these CMOS. And then this, what, for example, if you write this function, then this tool will take one OR gate. For example, OR gate is doing the addition function, right? So you are applying two input and then you are getting one output. So A, B, and yes, of course you have a carry and so on. But now this is just for an example. And this is what you are going to have, this tool is going to perform, and this tool will give some kind of net list. This is after the synthesis, you will get the net list. This is the net list. Of course, you have to do some more post simulation and check everything is okay. There is no time delay. The time delay is correct, and there are no other errors, functional errors. Then after you make sure everything, then you send this net list to the company who is going to fabricate the chip. And for example, TSMC, Taiwan Semiconductor Manufacturing Company, or you can send to the UMC. This is an American company, and this is a Taiwan company. Or you can even use the ST Microelectronics in Europe. So they will fabricate this as a chip, and then they will add the input, output, pin, everything based on your design, and they will give you as a chip. So, and you are using this chip and you are designing the PCB using this microcontroller. For example, this is a microcontroller, then you can use this microcontroller and you can design your PCB for the system, whatever the system you are intending. So that is what we had seen, the difference between microcontroller and microprocessor. So microcontroller has everything is inbuilt, but microprocessor is not inbuilt. You have external memories and external peripherals. Okay, so VLSI, please try to have some idea about this VLSI because you are going to graduate soon. As a digital electronics students, you should know what is digital electronics. So you have studied about analog electronics in your course last year, electronics. Digital electronics is really based on this VLSI. The VLSI, I told you here, we can write this program. So you can use this VHDL or Verilog. And you can write this program and the synthesis, and then you will get the net list, and then you will send to the company, and then you will fabricate and so on. Okay, so remember, so this is the high level. If you really dig into inside, then finally you will end up with this CMOS. This CMOS is working based on this principle. So this is what we are using here in the microcontroller. So we are learning into more detail, in-depth detail, how it works.